look at the tests and then interpret the results. But at first, I want you to know there are three pieces of information we're going to look at. And the last piece would be distribution statistics, and that's skewness specifically. And we know if this is normal, when the distribution is skewed, we either have positively skewed or negatively skewed. That means your distribution is not normal. And in that case, you cannot generalize your results from this sample to the bigger population because it's not normally distributed there. And that's why we need to look at this before we do the test. Otherwise, if we do not know whether our results can generalize, what's the point there? So it may be reliable or not reliable. So we have to do this first, and then we know what to do with the results, the correlation or the group difference. So with that said, we are looking for three pieces of information in the output and where to find them. And it's nice because we get all three pieces with explore alone. And the first piece is the visual. And here's the visual for college experience. And we already know how to add the curve. You can double click to activate the editor. And then there's a curve button right above the graph. Here, show distribution curve. And you click that, and then it's added. And you have more options to define what curve you want to add, but we'll leave it as default, which is normal. And so we close that, and we'll close the editor window, and it's added. And also you can add the mean as the reference line. To do that, it is above here, right here, this icon. Add a reference line to the x-axis. And so you can click that, and to identify the reference line as the mean, you can go to this box and select the mean or median. And so we will know how the distribution is in relevance to the mean. And here it is. And here's a question for you. So based on the histogram, do you think its college experience is normally distributed? It's actually very hard to come to a conclusion based on the graph only, right? It can be very subjective, and it seems it is high in the middle and low on the sides, but not exactly normal, perhaps. So we're not sure. And that's why we need multiple pieces of information. And that's the first piece. And I think Lauren just asked about that, how to paste. To paste this from the output to your Word document, you can just right-click, like you will do any Office software again, and then there's copy. And you can go back to the worksheet and just Control-V and paste it here. Of course, it's a huge graph, and you can rescale it to something like this. So we have that first piece of information, and we'll keep going to the normality test significance to see if that helps us to reach a conclusion. And it is right above the histogram and below the descriptive table. And here, as you can see, there are actually two tests. One is called, I'm not going to butcher the name, it seems it's either from Russian name or, I don't know, Uzbekistan or something like that, because they're this Smirnov, but I shortened it for KS, and then SW test. But what you need to know is both tests are normality tests, and what we are looking at are these significance columns. I already highlighted, let's see. Oh, I remember, actually it's here. I already ran it before class and highlighted the results so that it's better for you to see. What you need to look at is these two columns. These are p-values. Remember p-values as probabilities over there. And specifically, we are looking at something p greater than 0.5. And to give you a quick explanation, because we want to know over 95% of the time it's within that range, right? So that we know there's a significant difference or something. But for this specific test, we want no difference, because simply put, the assumption there is to compare the distribution of your data and the normal distribution. So you do not want your data to be different from normal distribution. You want it to be the same as the normal distribution. So we are not looking for significant difference, but we want no significant difference. Does that make sense? You wanted your distribution to be the same as normal distribution so that you can conclude it is also normally distributed. And so we are looking at something greater than that. Otherwise, we will be looking for something smaller than that, and we will see
Question.
in a minute. Yes.
Is that 0.05 or 0.65?
0.05.
Okay.
Yes. And in other words, that means 95 chances of some results. So it's not 65. That's not almost never used as criteria for p-value. So you know that's a wrong value. And it can be 0.05 or 0.1, and sometimes, very rarely, 0.10. That's too lenient a significance level. And speaking of that, because we are talking about significance, this is probability value. It can be any value. And to answer your question, Aaron, it can be 0.65. It can be 0.95. For probability, it can be any value. But these here specific values identified as criteria, these are called significance level.
So you want your significance levels to be smaller, so there's a greater chance that it's actually accurate?
Yes. For example, in life and death matters, in medicine, you wanted it to be 0.0001 or even smaller.